Today, we'll start with, the focus of the permitting process and really using green infrastructure to help make your site compliant and economically developable but still meeting new regulations and permitting requirements. So just to start off with where we're at. This is our current stormwater ordinance here in the city of Grand Rapids. This are the requirements that need to be developed on any new construction site. Within the city of Grand Rapids, a permit's required if there's a disturbance of 1,000 square feet or more. That's been an ordinance on the books since the mid-90s, and really we utilize that here in the city because a lot of things can happen on acres smaller than or on sites smaller than an acre. The acre requirement's more of a common requirement in DEQ regulations and things of that nature, but within the city, in our development patterns, we see smaller sites, so we have permitting requirements for sites that disturb 1,000 square feet. One of the areas we have ordinance requirement for is for water quality. So anytime you're creating a new site or changing a parking area or adding new parking, you're required to treat for the first 1/2 inch of runoff from that area. So that's treating the water runoff for suspended solids, greases, and oils, and other contaminants to make sure that runoff from your site is clean. Another requirement we have in our stormwater ordinance is for channel protection. So basically to ensure that downstream systems are not overloaded with additional runoff from new development, we have discharge rate requirements and water detention requirements that I'm sure a lot of you are familiar with. In that same sense, we also have a flood protection. This is what you're designing for your stormwater detention system, either your 25 or 100-year storm. For example, we are in the Coldbrook Creek Drainage District right here in this building. Any type of intense summer rainfall, our manholes pop out front. So this is a 100-year design storm area, so you're required to have more on-site detention to help mitigate those issues. So those are just the broad overstrokes of where we're at with our permitting requirements.
So the fact sheets are going around. Again, each fact sheet has the maintenance, the cost information, just the general guidelines, and it's made so you can make yourself a whole manual, or you see how we printed them. If you print the 4 pages for one fact sheet on an 11 by 17, you've got a brochure to handwrite to your client. So we'll start with porous pavement. That's the one that the city's been doing for quite some time. Some of the key things, obviously you always need to have good sandy soils, or you'll need an under drain, but if you want the best out of your porous pavement, you'll have sandy soils beneath it. One of the greatest things we've learned is if you have a parking lot, you don't have to have the entire parking lot porous in order to infiltrate the runoff from that parking lot. So if we look here, this is the Easttown Hub lot. They just basically did maybe a quarter of the parking lot where it runs into the street as porous to infiltrate from that lot. One of our favorite things to do is parking lanes. So these are actually paved drain, which are proprietary, and those will give you the biggest bang for your buck for your storage. But even with just a porous parking lane and regular drive lanes, you'll get enough infiltration to take what's coming from the road. Now, we typically team that up with a bulb out rain garden and some infiltration basins along the way. But so you don't have to worry about, oh, we can't afford, or we've got trucks coming in this part of the parking lot. You can keep your heavy traffic off the porous parts and just put it in parking spots or a certain entrance that is not the truck route through the site.
Okay, so when we look at the water quality requirement, one of the main focuses going forward in your design is going to be your TSS removal. And as I said before, you're looking for that 80% reduction. That's your benchmark for compliance. And what I put in this chart here is a list of some of the commonly used stormwater BMPs and the TSS reductions that were proposed to the state in our approach to meet these requirements. And so this is based on data that we use from all over the world, a lot of it here in the US, but there's also green infrastructure happening in other places, and we wanted to tap into that as a resource. So when we look at our TSS reduction, these are in percentages, you'll see that a lot of them are below that 80% threshold. So in order to achieve that 80% on a site design, you're going to need to combine these and use them in a treatment train type setup. And you know, a lot of these have the added benefit of, because they are providing that infiltration, they'll also help you meet your channel protection requirement. So they really do serve both purposes. And if you're able to infiltrate all of the stormwater on your site, then you'll automatically meet that TSS water quality treatment requirement, because there is no extra flow leaving your site. So therefore there's no reduction required. Does that make sense to everybody? So when we look at these percentages of reductions, it very quickly became obvious to the communities that are working together on this approach that we needed some kind of a tool that designers could use to be able to run potential scenarios on their site, look at their design and look at the site conditions and determine what was going to be the best option for them. And so what we created was a design spreadsheet, and we've provided a copy of that. It's an Excel file on your flash drive, so please feel free to open that up, take a look at it, and play with it. There's kind of two different areas where you can put parameters in. Green areas are going to be fields where you're going to enter information about your site, so numerical data. Yellow fields are going to be more drop-down menus where you can choose from a menu of items like the BMPs that you're proposing to use, or what kind of soils you have, that kind of thing. And so with this calculator, what you can do is you can input the parameters of your site design, and the calculator will help you determine if you have met your design requirements for water quality, for water quantity, and for flood control. And if you haven't met those requirements, how much ground do you have left to make up? And at that point, then you can look at adjusting your site design or utilizing one of the alternatives like mitigation or payment in lieu, or if necessary, utilizing an alternative approach. But this entire green infrastructure movement and the new stormwater standards are really going to require a very fundamental shift in the way that we look at site designs, because we've moved away from this model of putting a detention pond on every site, and now we're looking at ways to infiltrate that stormwater and then do a much better job of cleaning the stormwater that we do discharge, so that we're not contributing to non-point source pollution in our surface waters, which, as you know, is where our drinking water comes from. And that's really the end goal here. So if you have questions about the stormwater calculator, you're more than welcome to reach out and ask me. You can ask Carrie. Here in the city of Grand Rapids, as Carrie and Dan have mentioned, there are areas that require the 100-year storm for the flood control and areas that require the 25. So that's something that you can kind of look at a little bit more closely within the calculator, but it's really a valuable design tool. And in addition to making the process simpler and more straightforward for the development community, it's also going to help to streamline your review and make it much more objective and simple, so that you know going in that you meet these site requirements, or that you have additional ground that you need to make up, and you know exactly where you stand.